to our study of functions here. And again, now we're going to look at some properties of these functions. Again, functions being the mathematical models that we apply to real life to try to better analyze or optimize or predict. So these functions aren't just some boring thing in a book, algebraic description. This is money. This is how you make your money. This is how you find the cure for cancer. These functions might be describing how to get a better battery life to make electric cars viable. So when people get together, sometimes they're just talking about that function and some characteristics, so they're very interested. And again, there'll be a certain function applied to a certain application. But back to our properties, a little motivation, but here's our properties. Here I use different notation. And again, remember, notation is what makes things hard for some students. And I think when I was your age, I don't know if I could necessarily read some of the functional notation. But here I got a U. U is my input. Again, here's my machine model. U goes into this function H. Okay, I just put in H here with parentheses, meaning it's a function. It's going to take a U and produce a Y. So if I notice that this thing, when I put in one U, I get out one Y. I can't put in one U and get maybe, I can't put in a U of 3 and maybe get a Y of 9 or maybe negative 9. I mean, that wouldn't be a function. I put in a 3, I get out a 9. There's kind of a one input to one output. So if I drew a function like this, I drew it on a graph. Back to green, we'll go to green here. Well, let's see. I guess I'll put a U here, and I'll put a Y equal H of U. And now you see maybe I've got some function that looks like this, and this would be a function. Notice for each value of U, I get one value of Y. Maybe I've limited my domain from here to here. And my range, so this would be my domain. My range then would be from the max down to the min. But notice for each value of U, there's only one value of Y. Now, what happens if this thing kind of curled back on itself like this? It went like that. Okay? Well, look at the problem here. Look at the problem right out here. If I zoom in on this, I have 2 points. For a particular value, let's just call this value 10. And if I put in a 10 here, apparently I can get a 10 input and a 5 output, which is that point. Or I can put in a 10 and get out a 4. This, again, let's go, we better put something. That means that is not a function. Not a function. And it fails with something we call the vertical line test. Fails vertical. That's a E. Vertical line test. And again, you had learned that before. I'm bringing it back to you. And think about how intuitive it is. If you put in a 10, a machine's only going to give you one output. It doesn't give you, well, 5 some of the time and 4 some of the time. It gives you one output. It's a function. If it's not a function, we might call it a relation. If it's not a function, I might use the word relation. Here, I'll give you some common relations that you've worked with before, and they're not functions. How about this? X squared plus y squared is equal to 16. What's that? Well, I'm hoping you recognize that as a circle, right? That is a circle. Trying to draw a nice circle here. I actually could get real fancy and have a circle inscribed on here, but I won't. And a couple points on the circle. Remember, a couple points here. Let's see, that point right there is what? Well, x is equal to 4, y is equal to 0. How about this point here? This point is 0, 4. What about that point? Well, that point is 0, minus 4. This point here is minus 4, 0. Clearly, this is a circle, but not a function. Not a function. Why? I guess I can, let's go lines here. Yeah, we'll get a line, see if I can, my line color is not right though. I got a line, but I want it to be blue. Okay, well anyway, here's my vertical line test. You can see right here I've got 2. For this value of 3, I've got 2 values of y. It's not a function. It's a relation. The circle is a relation. Now if I wanted to put this in my calculator and actually plot it, I could turn this into 2 functions, right? I could turn it into this function on top. What are we going to make that? Green. We'll make the bottom one red and the top one green. So I could say, well, y1 is equal to what? I got to make this notice what do I have to do here? Let's do a little magic. We're going to say y squared is equal to 16 minus x squared. I'm going to take the square root of this. I'm going to say y is equal to square root of 16 minus x squared. But remember, that can be plus or minus. Because I can square the negative side and get, when I square it, it doesn't matter if it's positive or negative. So y1 could be the one in green here, right? Y is positive here, right? Y is positive, so this is going to be positive, the square root of 16 minus x squared. Y2, which I guess is in red, let's do that. Red, y2 is going to be what? Well, y's are negative down here, right? They're below the x-axis. So that's negative, so it's going to be negative square root of 16. Okay, so properties, you have to, a function has to pass the vertical line test. Here's an example of a relation that's well known, a circle, and it's not a function, but we could divide it into 2 functions here, 1, 2. Okay, another property of functions we should be well aware of is symmetry in functions. And when we talk about symmetry, we usually talk about even and odd symmetry. So the first type of symmetry here we'll discuss, let's call it even symmetry. And recognizing this symmetry in functions can simplify problems greatly. So, even symmetry. Okay, so graphically, usually show this thing graphically, and even symmetry means I can reflect it around the, if I use my trig functions, which I like, here's try to make this. Here's symmetric. This is what? Well, what is that? Do you recognize that? If this is x, if this could be my cosine of x. Cosine of x, this is a symmetric function, meaning if I take any value here, if I take any value x, and this is x, this could be 1, and this could be minus x. I better get the same value at x and minus x. So there's the definition of symmetry. The function at x is equal to the function at negative x. Okay, so you can see in the case of the cosine here, the cosine of, I don't know, let's say pi over 4 is equal to, is that equal to, maybe it's a question, is that equal to the cosine of negative pi over 4? Is it true for all x? You'll find out it is. Just a property of the cosine. That is true. Cosine is an even function. Okay, how about if there's even function, even symmetry, you might guess there's odd symmetry. Or they might call it symmetry with respect to the origin. Here, I will give you a, since we're talking about trig functions, what would be that trig function coming to mind? How about the sine of x? So here, oops, that is not such a good drawing there. Odd symmetry says the following. If I put in an x value here, I get a f, I get an x, right? And I get an f of x. If I go out here, if I go x units to the left of the y-axis, I better get what? Well, this better be the opposite of that. So this point better be minus x minus f of x. Okay, this is the definition. So the definition of odd symmetry is that the function, oops, let's see, this is wrong here. I gotta put a negative here. The function of negative x is equal to negative the function of x. Or maybe to make it consistent, you could say, well, f of x is equal to negative function and minus f of x. Okay, odd symmetry. So you'll see that in your homework tonight. You have to identify as a function is even or odd. Okay, see you soon.